This video is video 8.1 and this video is based on calculating the average rate. As you should know, the rate of a chemical reaction changes over time. It is usually fastest at the start of an experiment and becomes slower as the experiment proceeds. This is due to the reactants being used up and their concentration dropping, which means that the remaining reactants are not colliding as often. There are two ways to measure the rate of a chemical reaction. The first way is the average rate, which we're going to do in this video, and the second one is the instantaneous rate, which you can see in video 8.3. We've highlighted average rate as a key term in this book. The average rate is the rate of a chemical reaction over the entirety of the experiment. There's a formula for how to calculate the average rate, and it's just the total volume of whatever gas has been produced over the total amount of time the experiment took place. On the left of the screen, you should see a table. This table documents the volume of oxygen gas produced in a particular experiment over 100 seconds. Values for the volume of oxygen gas produced were taken every 10 seconds. Using this data, we should be able to calculate the average rate of the chemical reaction over the time of the experiment. The formula for calculating average rate is seen in the centre of the screen. In this particular experiment, if we were looking at calculating the average rate, all we have to do is fill in the formula. So in particular, the average rate here is going to be equal to the total volume. And the total volume of gas that was produced in this experiment was 11.5 millilitres. You'd then divide that by the total amount of time, and in this experiment, the total amount of time is 100 seconds. When you filled out the formula on your calculator, you divide 11.5 by 100 and you'll get the answer of 0.115. With this, we have to include our units too. So in particular, we have to make sure that we add in millilitres per second. Therefore, in this experiment, the average rate of reaction was 0.115 millilitres per second. What that actually means is that for every 1 second in this experiment, 0.115 millilitres of oxygen gas were produced. From watching this video, you should be able to calculate the average rate of any chemical reaction if you're given the total volume of products produced and the total time it took for that volume to be produced. In particular, you should be able to use this video to help you answer the questions that are on the optional student handout that comes with Activity 8.1, where you're asked to calculate the average and instantaneous rate of a chemical reaction, and that reaction is the decomposition of hydrogen peroxide using manganese dioxide into oxygen and water.